Or is everyone already settled down, I believe? Well, everybody, once again, a very warm welcome to the second conference of Green Hydrogen 2024. And we are here to discuss on addressing safety concerns through regulation, codes, and standards in hydrogen ecosystem and collaborative approaches for building, testing, infrastructure for green hydrogen electrolysers. And I am now I may invite all the panelists on the stage. May I now request Mr. Deepak Kumar Aggarwal, scientist FBIS, to please join us on the stage. Thank you. May I now request Mr. Srinivasa Rao to please come on the stage, our controller of explosive, petroleum and explosive safety organization. I now request Shri Kishore Pande to please come on the stage. He is our Joint Director, Process and Engineering, Oil Industry Safety, Directorate. Thank you. May I now request Professor Rahul Nabar, Adjunct Associate Professor, Department of Chemical Engineering, IIT Bombay. May I now request Dr. Sturle Harald Pedersen, Chairman of the Board, to please join us on the stage. And I also request Mr. Jorgo to please come up on the stage, our CEO, Hydrogen Europe. And ladies and gentlemen, our moderator for the day, for the panel discussion, may I now invite Mr. Hemant Mallya, Fellow CEEW. Thank you so much, everybody. He'll be taking care of all the panel discussion. Thank you.
Okay, great. Good afternoon, everyone. If you don't mind, if you can just get the door. It's such an exciting topic that I don't want anyone to get disturbed. We are a little bit late in terms of our, start time. So I'll keep the introductions very short and run straight into the discussion. Jorgo, I think, is running a little bit late. So whenever he joins, he'll join us. But I'll introduce, all of the panelists, including him, and then we can jump into the discussion. So I'll start with Sturle on the extreme left here. Maybe you can just say hi so that people know whom we are talking about. Sturle served as the president and CEO of JEXCON, if I'm pronouncing it right, a global leader in safety and risk management. His work focuses on the development and implementation of rigorous regulations, code standards that ensure safety across the hydrogen value chain. So very pertinent to what we are discussing today. Next is Professor Nabar. He teaches in the chemical engineering department at IIT Bombay with a focus on applied and industrial topics. Professor holds a PhD in chemical catalysis from the University of Wisconsin-Madison and actively consults with companies in the Indian chemical industry, especially in specialty chemicals and now, green hydrogen. Mr. Nawal Pande, sitting to my left, is the Joint Director of Process and Engineering at the Oil Industry and Safety Directorate. He brings a blend of expertise in safety audits, accident investigations, and imparting HSE training. His extensive experience at GAIL and Reliance also include petrochemicals and fiber industries, very important, as in the future, green hydrogen probably will see applications there. Now moving to my extreme right, Srinivasa Rao is the controller of explosives at PESO. He has more than 25 years of experience in the fertilizer, oil, and gas sectors. He's representing PESO as a member of the working group of National Green Hydrogen Mission on matters related to green hydrogen regulations, codes, and standards, and then in the drafting committee for preparation of draft amendment rules of gas cylinder rules, and then a whole bunch of other rules that I'm not going to list. To my right is Shri Deepak Kumar Aggarwal, Scientist F, and he heads the Standards and Coordination Monitoring Department at BIS. He has over 25 years of work experience in various activities at BIS, and then I'm sure we'll have many questions for him. They are in the spotlight. And then finally, Jorgo, I don't see him yet, but I'll introduce him anyways. Jorgo has been the Secretary General of Hydrogen Europe since 2016. And before that, he was a representative at Infineon Technologies in Brussels, where he contributed to laying the cornerstone for the first and second joint undertaking on hydrogen and fuel cells. So he'll join us whenever he can. Uh, so in terms of just the structure of our discussion today, I'll have two rounds of questions for all the panelists. The first primarily focused on standards, and then subsequently looking at testing infrastructure. But before we begin, I think it's important to set the context on why are we talking about safety. And Mr. Pande, I think no person better than you. You have seen the gas industry, intimately. In fact, I personally have had experience working with you on gas leakages, etc., which is becoming a central focus, in terms of hydrogen. And everybody's talking about, hey, what if there's a hydrogen leak? And now you're at OISD, looking at the oil side of things. Now, just dialing the clock back a little bit. It's not that safety has not been a concern for the oil and gas industry. Safety is as much as a perception as reality. I'm sure if we Google gas explosions, we'll find many incidences, and yet we have taken it into our consciousness that there's an acceptable risk. So clearly, we have seen these challenges in the past. Gas was new, and people were worried what happens if a gas pipeline bursts open. Same thing with LPG before we, transition from kerosene to LPG. So the concerns are new for a different fuel, but they're not new for the industry at large. So how do we deal with the perception issue? Because eventually the standards can only take care of the science part of it, but the perception remains. So I just wanted to set the context before we actually get into the standards and infrastructure discussion. So over to you.
Thank you, Hemant. I can really recollect those days when we used to go together and find out where are the fugitive emissions. So in terms of just setting the tone, you are absolutely right in saying that the perception is the most important thing. What is happening in case of methane is the global warming effect of methane was an important concern to find out or catch or map the fugitive methane emission. And that fugitivity of hydrogen is much more. This is the smallest molecule and viscosity is the lowest. So any damn small passage will be a leakage for hydrogen. So the more concern of fugitive hydrogen is there. Secondly, now the discussions on as far as global warming goes, discussion that hydrogen and methane stoichiometric ratio in atmosphere will change in case you are allowing the fugitive hydrogen into the atmosphere. So that is again, it is a subject of discussion, research. There are research papers which are saying so. But yes, as far as safety is concerned and the perception is concerned, the most important thing is that the initial accident should not take place. You should not make this hydrogen initiative in another Hindenburg. Because in case of Hindenburg, hydrogen was not actually responsible. It was the another cellulose nitrate and the gasoline part that was more responsible. We did not much studied hydrogen in terms of its quality, in terms of its physical properties and chemical nature. So in order to build the perception right, we must go slow. We must follow the standards, safety standards. We should understand what are our limits. You want to welcome? Okay. So as far as planning a hydrogen facility is concerned, first of all, we should identify the hazardous areas where it is. We should maintain our inventories. In those cases, the R&D infrastructure and the studies and reports coming from those infrastructure is very important, because we do not know how small hydrogen can create how much bigger explosions if you compare in terms of its devastation and its detonating power, because hydrogen can immediately quickly go into the detonation range without much efforts. So devastation of hydrogen with lesser inventories are also possible. So we must be very careful about scaling up. So these are my initial comments about what kind of perception we should build. We should not expand ourselves too fast. First, we should learn our pilot studies, and we should inculcate and incorporate those results, risk studies into our actual practice.
Great, thank you. And I think you said it right that we need to be careful in how we scale up. And I think we are seeing perception-related issues on the EV side, where some of the battery fires are making people rethink on whether EV batteries are safe or not. Of course, the oil and gas industry has had a century, but Mr. Aggarwal, you get a decade to what they did in 1 century, right? So although safety is a concern, but there is also the push to drive hydrogen ecosystem very quickly. So you don't have as much time as you did on the other energy fronts, and we'll have to very quickly scale up, which means that without the standards, which are the enablers, operators cannot really do a whole lot. So how does BIS plan to address this challenge of trying to bring in standards, either adopt, adapt, or develop own standards in this short span of time that is the expectation of the ecosystem?
So thank you very much. Good evening, everyone. As rightly said by Mr. Nawal Kishore, that perception is there, that safety concerns are there, that will remain for some time. But our experience is that over the years, yes, PESO and standards and regulations and everything, they have taken care of the safety of the consumer, barring few accidents. And very rightly said, life, every individual's life is important for every one of us. But that should not be a deterrent for us to go into a newer technology, which gives us a leverage of having reducing carbon footprint, reducing global warming, that we all know. Now coming to, because all of us are, as far as our country's context is concerned, regulations and standards still we feel are at nascent stage. They have matured to some level, but they are yet to be at that level where we can start implementing at the ground. And of course, our PESO will definitely aware about inclusion of standards in the regulations, rules they develop. And prime most concern is safety. Although we take three factors while we formulate standards, safety, performance, and then some commercial practices. But of course, in the case of these explosive kind of gases, the prime concern is safety. I mean, it takes over all other things. So concerning safety, we have started working on it. And of course, the first task given to us by MNRE, they identified 49 standards. We developed 41, and some are at development stage. That is phase number 1. Phase number 2, they have identified 79, and majority of them are addressing the safety concern at production stage of the hydrogen, then a storage stage of hydrogen, maybe it is gaseous or cryogenic stage, then dispensation, of course. Then, of course, stationary applications have different challenges, and mobility applications have different challenges as far as safety is concerned. So that part we have to sit together, we have to discuss with the stakeholders we are having on board in our BS team. And wherever research is required, we'll onboard our expert from the academic institutes also, and R&D institutes also, DST also. So we are tapping all the resources that are available with us, so that we give a standard which is kind of safe for the user.
Thank you. And we were partly involved with the mapping of the standards, and we see that BIS is moving really quickly on it. Jorgo, is that pronounced right? Jorgo, yeah. Welcome. I did not announce about your background, so maybe jumping in straight into the discussion. BIS is doing its part. But then we see that there is action globally. So there are multiple countries, regions that are developing their own standards. there's an opportunity there. One, which is, can we collaborate to accelerate the development wherever possible? Second is, to a certain extent, interoperability might be essential, especially if you're looking at manufacturing electrolyzers, fuel cells, and then exporting. We will have to adopt or adapt to international standards as well. So what do you think are the efforts that are needed at a global level for different countries and regions to collaborate? And what mechanism do you think can, work out other than just bilateral conversations?
Thank you very much, first of all, for the invitation organizing this and putting standards also prominently into the conference. Normally, standards are dealt with somewhere, in footnotes, but they are very, very important, as you say. And who of you has seen hydrogen accident or heard about hydrogen accident lately? One, two, there are a few. Yeah, so these accidents are important to improve. We don't want accidents, but we know that accidents, whenever they happen, they lead immediately to a bigger awareness and also better handling of all this. I'm in my 5th year of driving a hydrogen car. So I'm driving the hydrogen Nexo. And so I know all the safety standards around mobility, the fueling, the car, the sensoring of everything. And even if there is a doubt, I'm now struggling with the authorities because there were sensor problems at 2 cars and they called them all back. So I said, I cannot, no, you need to come back and you need to check your sensor. But I love this. It shows that the hydrogen sector is very well aware that any accident can cause mistrust problems, so confidence problems. So safety absolutely first, and this is a very, very important element. Similarly, it applies now also to electrolyzers being important in systems. You don't have this problem in India with curtailment. You have a very strong power grid. Most European grids are smaller and start to have big problems where electrolyzers come into the system to balance these systems out. However, if they do that, there is data which might be produced and used or abused. So we now come into a next phase of safety standards. Who produces the electrolyzers needs to comply with certain safety standards given by the member states, in our case, or by the European Union. This is new, not so relevant for you for the moment, but if you produce electrolyzers for the European markets, you might want to have a look at this new development. I can also clearly say that Chinese electrolyzers dominating the market might have a problem, which is a big chance for Indian electrolyzers. But now to your concrete questions, where to do this collaboration, because it's not only about safety, data safety, it's also about counting carbon footprint, because this will be the decisive factor of all hydrogen markets, whether you are able to reduce the CO2 emission amount and how to count it, where to start, where to stop to count it. And here, Europeans have a very tight idea. Indians might have a broader, more pragmatic, and more, in my view, a better idea. The place to deal with all this is called International Hydrogen Trade Forum. It exists. It was launched in Dubai during the COP last year. It will be renewed this year in Azerbaijan. India plays a role there, but India could be more active. This is led by the Netherlands and the United Arab Emirates, and it's super important because here many, many countries agree upon standards that might have been evolved in India, in EU, but if you agree collaboratively upon them, this is the way it goes. We need this global acknowledgement of these standards, otherwise the markets will not scale up. So all the work that has been done on that level, also on the IPHE level, the International Partnership of Hydrogen in the Energy, so it's an old name, but this is also a very, very important collaboration. Many, many participants are here. I think it's the oldest hydrogen association on an international level. Very, very reliable. And of course, China is in. Of course, all the countries are in. And this is also very, very reliable. But we need to bring it to the next level. Our idea is to create something we have in the renewable sector, IRENA. You have heard about IRENA, or the nuclear energy sector is also an international agency on nuclear energy. That's what we need. That's what we want. We started to talk to the host of next COP, Azerbaijan, to put it possibly already into the conclusions of that COP, but it should be in the conclusions of next COP in Brazil at any, in any case. We need this international agency where all these standards then are collected, but also monitored. And this is where we Europeans, as a business association, we are working for, because it's crucial for the upscale of all technologies. Thank you.
Thanks, Jorgo. Clearly, the concurrent theme is that perception should be managed, very early on. And I think the most visible application is going to be in the transportation sector, as well as, storage of hydrogen. So, Mr. Rao, coming to you, clearly we see that given that hydrogen is such a light molecule, it'll have to be transported at much higher pressures than, say, natural gas, if you have to keep the, similar flow rates. So how does PESO plan to address some of the safety concerns as far as storage and transportation is concerned?
Yes, sir. Good evening to all. First of all, we should know what we are handling. That is hydrogen. That is the least low density gas in the world. And we are handling in refineries for so many years. And the challenges now, because it is coming from refinery to the public as a dispensing stations. And there are 3 steps, because safety is the prime concern of PESO, safety first. And the main concern is the production, then storage, transportation, and utilization. There are 4 steps, and then exports. This is our goal of India. So we are actually now prepared rules, patterns to the hydrogen, inclusion of hydrogen in the amendments. Recently, we have a draft rules and we have publicized to public, and we got suggestions from all the stakeholders. So whatever the related to the safety of concerned with the safety in India pertains to India, because we have referred almost 52 standards, and we have taken from NFPA 2, that is hydrogen technology standard, and ISO 19880, that is the fueling station standards, and so many EN standards for the type 4, because it is a big infrastructure related to this. Each stage is huge. Level of safety concerns are there, a variety of concerns are there. And for this, how to decide the safety distances and what is the layout? This is the main concern. Because if you want to keep something in your house also, you have to put the proper place. Otherwise, if it is fell down or something, you have to see the safety first. So like that, if you are keeping the hydrogen in such a way, the safety distances, what is the safety distances? How to take the safety distances? How to implement to the Indian conditions? Because we are highly densely populations in India. In the world, we are highly densely populated, and our atmospheric conditions also different from different area, because there is a huge variety of different atmospheric conditions we have. So this gas is the least, and the main issue is the leakages, what we have observed in our trail runs also, because we have given some trail runs to IOC, LR&D, and the Reliance Jamnagar. So in that we have witnessed some of the factors, and we have conducted a risk analysis, risk assessment, and based on the risk assessment, and we have coordinated with the other standards, international standards, for the safety of the things, and we have achieved the Indian distances are more than NFPA 2. Because of this, because what he said exactly, the accidents, if your leakages are there, what is the, because 4% to 75% is the LEL and HEL of hydrogen. We know that. It's very much means dynamic in explosion criteria. It is like fire first, then it will be detonate also. It is a highly, this gas is differently, variety of dangers are there in this hydrogen. And the usage also, the activation energy also more, and its volume is less, That is actually the volumetric ratio, how to store these things. This is the first criteria for storage. For storage, we have pressure vessels. Because hydrogen, we can take it in two stages, because gaseous stage and liquefied stage. Gaseous stage, that should be pressurized, because if you give high pressures, then only we can store more gas. This is density. Because high density you have to achieve. Otherwise, there is no point of view for going for this hydrogen, because the main criteria is the pressures handling, and then what is the thickness and what are the jet fires we are achieving for these leakages. These are the things we have to be analyzed, and we have all the studies in that, and then we have prepared a very good draft rules, and we are finalized it also, and it will be published within 2-3 months, because within 2 months time it will publish also. So the main concern is a huge subject for storage, transportation, and utilization, because there are 3 stages. One is, there are so many installations are there. If you see the pressure vessels, you can go up to 150 bar for the pressure vessels. And pressure vessel is different from the tanks. Tanks is different from the pressure vessel. Don't confuse this. Pressure vessel is a vessel which is having 1000 liters water capacity. Above 1000 liters, it is a pressure vessel. It is not a tank. Tank is tank and tanks, the terminology in US and other countries. But in India, we are making it as a cylinders, gas cylinders. These gas cylinders, we have below 1000 liters. But as a compressed gas of hydrogen, in our rules, we have increased the diameter of the pressure, the cylinder from 60 centimeter to 80 centimeter to collaborate, to coordinate with the foreign these standards, and we make the capacity to store in a tube trailers, 80 centimeter dia we are allowing in the new rules. This is the amendment rules, and we have created a dispensing station also. Dispensing station, what are the safety, what are the conditions to be followed, and what are the safety distances as per the NFPA 2 codes. And coming to the point of cryogenic liquid hydrogens, because liquid hydrogen is at minus 253 degrees centigrade temperatures. And the main issue in the subcooled temperatures of cryogenic temperatures, it is a process is highly economically, as of now. It's not, means now it is going on standards, but the process is entire one plant you have to construct for the cold box and all, like nitrogen and oxygen. And this is a flammable gas. There are so many targets are there, and we are considered all these LH2 liquid hydrogen station also. We have been incorporated in SMPV rules, and gaseous storage tanks we have incorporated in gas cylinder rules. So the challenges and safety concerns, we know, everybody knows that what are the safety concerns, and we have to follow the regulations as a regulatory body. If you follow the safety distances, because it's a practical experience for me. When I investigated one accident in a steel plant, there is a big accident. Oxygen exploded. Oxygen is very dangerous gas. If it is coming with, because 0.012 millijoules, it will explode. Total plant has been melted, all the walls. So these are gases are not so easy to handle, but we have to take care about the robust engineering design and material selections and engineering P&IDs and sensors, detectors. All these are a very big subject, this is. So we have to take care of all these things, and we have to grow slowly. It's not like fast, immediately we'll go to this. First of all, we have to study it. We are under trial runs now, and we are getting good reports from Reliance Industries and R&D, IOCL. So based on that, what we have to step on, because if anything happens, something, so the effect of that, so many things will happen. So that we have to keep in mind, safety point of view. So generally, we have to invent green hydrogen is our future, and we will do success also because of safety. We can do the things well. This is my.
Great. Thank you, Mr. Rao. Clearly, safety management is a function of both standards and better engineering. But Professor Nabar, engineering can never be 100% perfect. So then it comes to management. When it comes to natural gas, we know there are, credible, time-tested technologies. We have sensors, we have infrared technologies. how do we manage hydrogen? Because that is a very important safety concern, and not just from safety, but also public perception perspective. So your comments.
Thanks.
You need to switch it on.
Yeah. Thanks, Hemant, for that question. So I think, hydrogen is quite unique as a molecule. I mean, it doesn't have a dipole. So a lot of the other stuff, IR, some of it doesn't work. But on the optimistic side, right, hydrogen isn't new. So for example, the petroleum industry has been using hydrogen for more than 70 years now. So I don't think we need, of course, there is always scope for fundamental research and coming up with new modalities, and that's happening. But I think the less glamorous part is the translational stuff, right? So I see, for example, the price of a sensor. Historically, while it was in a refinery, what is reasonable price for a refinery doesn't stay reasonable priced. What we're doing is we are democratizing hydrogen. Pretty soon it's going to be out there, the way CNG is out on the street, and no longer is a $2,000 sensor reasonable, right? So we're changing environments. So that's one of the non-glamorous parts at which we have to do a bunch of indigenization. The second thing I think is, in India, we all know about Jugaad, right? And what the Jugaad we pride upon is really not an asset when it comes to process safety. And you're not going to get too much of this when you are, in a refinery. You may still get it, but the moment it comes out on the street and it goes all over the country, we're going to see a lot of that, right? So the non-glamorous parts, how do I make something feel safe? How do I ruggedize a sensor? How do I indigenize it, right? So these are things which we have to do. At the same time, I think we have to be careful not to reinvent the wheel. And so in two areas, I think the petroleum industry, refining, they have a huge amount of experience. And so we shouldn't start from scratch for two reasons. First, we don't have the luxury of time. I mean, developing things from scratch and taking them to high TRL, it's a multi-year project. So we don't have the money, we don't have the time. So we should learn from what's out there. One, in terms of sectors, like a lot of the sectoral knowledge has to come into green hydrogen. The second thing I think is in terms of geography. And so I'm really happy we have somebody from Norway, somebody from Germany. There's a lot of knowledge in other nations. We shouldn't get into this trap of not invented here, right? So we should use our resources very wisely. So a lot of it could be by way of joint ventures, or how do you translate technology, bring it here, and things like that, right? So these are the non-glamorous parts which I think we need more work in. Another element is understanding what a sensor is. So when I talk to a lot of startups or the end users, the challenge they have is in figuring out, who's making a certain sensor, or, I know there is an expensive one from a foreign company. Do I have a cheaper alternative, which is indigenous, but it's also validated, right? You can't just take some technology. I mean, we all know a single accident is going to set us back. So the non-glamour, the dark spots are the things like, how do you find out MTBFs? In a refinery, it could be easier to calibrate a sensor periodically, but once it goes out there, do we have sensors that can last for 4 years? What is the life cycle of a sensor? And things of that nature. And people find it very difficult to navigate. I think, so that's another thing where I'm very happy CEEW is doing the work. I mean, here on the panel, we have 3 different regulatory agencies. And if I went out to an end user who's coming and, knowing what PESO standard versus BIS versus OISD is going to govern something, right? So this is the translational part of it, where communicating all that and making it easier for people to understand, I think that's where a lot of challenges lie. So although, as a researcher, as a professor, you would love to invent new things, but I'm feeling a lot of the high TRL areas, right? How do you translate and how do you harmonize it? One thing is we shouldn't invent new things. Of course, you should indigenize, but as far as possible, we should try to be in conformance with whatever standards are out there. There's a role for harmonization, so that you don't end up paying a price premium just because a special model has to be invented. And these mistakes have been committed. There's a lot we can learn from previous standards which have been out there. And so avoiding these pitfalls, I think that's, but I think the fundamental technology is there. I don't think we need a fundamentally new sensor. I think it's all these, the nuts and bolts, these details are where I think there's a lot of potential.
Thank you, Professor. And I think this is a point I like to emphasize often, is that hydrogen has been handled by the oil and gas industry for a very long time. It's very well understood as far as safety is concerned. But democratization is what makes financials very nervous. And Sturle, if you didn't follow what Jugaad means, it means patchwork. That's the closest translation I can get. But that means that the risk for a financial institution goes through the roof. New applications the fact that, people who have not handled hydrogen will be handling hydrogen, indemnity clauses, risk management, insurance, all of that is challenging. So how does, the industry deal with those challenges at both ends, the developers as well as the financial community?
Thank you very much, and good evening, everyone. Just before I answer the question, I would like to echo some of what has been said by the distinguished panel members. First of all, standards is extremely important that you put it in place. And I think that we shouldn't work fragmented. I think that we need to use this international organization. This is a global challenge, and we need global solutions. If we are not working together, then we will waste our resources, because India will work, Europe will work, North America will work. They need to come together like they do in ISO and some of the other organizations. But this needs to be brought all together so we can also monitor them, because we need to revise them. We see that Japan is now revising the regulations to make it compatible with Europe. And this is some work that needs to be done from all the different nations. So let us make sure that safety is something that we are working together on. When it's coming to the hydrogen assets and the uniqueness of hydrogen, I think that has been kind of covered. We talked about perceived safety, but we can talk about perceived risk. And I think this is one of the challenges that we have when we are moving forward now. We have a lot of knowledge, but we have a lot of unknown also in this area. So scientists and research needs to go on. We will never find the answers to all the issues that we will experience when we start now using hydrogen in different applications. So I would say that when it's coming to the pricing of your insurance going down the road, you would see a premium. And the reason is we don't have sufficient data. So we don't know what is the perceived risk. And the industry, the insurance industry, have a tendency to give a premium when they don't have the data and they don't know the frequencies of these accidents that will occur. So they will be on the safe side. And this is also an issue related to the regulations that is now moving forward. We don't have everything in place. So that means that there can be some compliance issues. We know that hydrogen is a naughty molecule in the sense that we have embrittlement, and this will also undermine the asset's long-term integrity. So that will be issues that will also bring in compliance issues for companies and so forth down the road. So there is a lot of uncertainty that will need to be priced into the premium of the insurance. Also, there is another issues that we haven't touched upon, if I may, and that is the issue about innovation. We have a lot of technology that we need to develop, improve upon, and so forth. And we need to strike the kind of the balance between safety, which is always coming first, but also innovation. So that's why it is important to monitoring also the regulations that we are putting in place. So we are updating to the technology. And today we have a descriptive set, which is the Bible, you can call it the safety Bible, but not everybody reading and interpreting this Bible in the same way. So that will also be a very important part, because PESO cannot kind of do this by themselves with the resources that they have today. I think that there is a lot of more resources that need to be given to this new area if we are going to be successful. And we talked about Hindenburg as well, that's kind of the last point. Let us not have another accident. Hindenburg is burned into our mindset about that catastrophic can happen and do happen. Even if in Norway we had an accident in 2019 at a filling station, but also in Germany we had one in June. So these incidents and accidents happens, and we need to be prepared. So if the public is losing faith in what we are doing, this could be a real challenge for our transition to a zero vision for Mother Earth. Thank you.
Great, thanks, Sturle. Mr. Pande, when we are thinking hydrogen, I think, Mr. Rao mentioned earlier, all gases are dangerous in different ways. Natural gas, you can put mercaptan and you can smell it. Hydrogen is different from other gases, perhaps because it's explosive as and when it comes in contact with air. So that is probably one distinguishing factor which makes hydrogen slightly more, or probably much more dangerous than, let's say, petroleum fuels. So how do we deal with that issue in terms of dealing with safety standards and safety management?
Thank you, Hemant. You have rightly touched upon the issue of hydrogen being explosive. I think this is the single most biggest danger of hydrogen. Apart from being highly reactive, so it and very small molecule, it goes into the crystalline lattice of the metal, and even polymeric substances are also not very suitable for handling this. So we need a lot of research in this. I think you are groping into the direction of R&D. That's why this question has been posed. So I understand. So going back to natural gas is handled in a different way. The detectors used to work. But here, since the size of the molecule is so fast, then whenever leakage takes place, it is also very important to understand where to put the detectors. It is sheerly because of its very small size and viscosity, because of the very low viscosity, the large amount of leakage took place in a very small leakage, or you can say the passage of, maybe it is a gasket or maybe a pinhole. So the large amount is there, but the detection is difficult. And one more important thing with hydrogen is that its flame blow off is at a very high velocities. So when it blows and the flame doesn't put off, and it is invisible. So invisibility of flame, and it is sustained at a very, very, very small length. For example, say 1 millimeter of invisible hydrogen flame, which is leaking from a flange, which it is very difficult to detect. So as far as placement of detectors are concerned, we need to study and we need to model based on the CFD that where these basically UV detectors has to be placed. We have to decide whether leakage prominently results into explosion or fire, or it will gather as a gas and becomes a cloud. So here you have to decide whether we have to put UV detector or we have to put a gas detector. So for that, you need a profiling. For example, usually in case of high pressure storage area, you need to have a UV as well, because there are more chances. If you have a high pressure storage and there is a leakage, there are more chances of fire. And another the peculiarity of hydrogen is that the mentioned Rao sir has also mentioned, it's from 4 to 74. Because of its very low stoichiometric need, it only needs a half a molecule of oxygen to burn, in comparison to methane and all. The methane needs 5/2, 2.5 moles of oxygen to burn. So that's why the range is very high. And again, its ignition potential is very low. It requires almost nothing like energy to ignite. And the third biggest problem is the detonation I mentioned, because the flame speed of once it ignites, and if enough ignitable mixture is available, the flame speed is very high. And when the flame speed high, then the wave front becomes high pressure and it crosses the zone of shock wave. So detonation occurs. So detonation is also a big challenge here. And again, if you talk about the reactivity, the embrittlement is an issue. In case of refineries, you find high temperature hydrogen attack, which is slightly different from another. So all these peculiarity of hydrogen poses different kind of risk. And again, there are certain myths as well. Sometimes people say that the Joule-Thomson's effect in case of hydrogen is reverse. Actually, hydrogen leaks and it temperature rises. But we have gone to certain investigation. I'm usually become a part of an investigation team, where if the fire or explosion takes place because of hydrogen, people usually blame it because of the Joule-Thomson's effect. The temperature went up to auto ignition temperature and it caught fire. But that's not true. Hardly the temperature rise cannot be more than 553 degrees centigrade. And if it is already gas is hovering around auto ignition temperature, then only it is a case. Otherwise, auto ignition temperature reaching because of the Joule-Thomson's effect is impossible. Secondly, when people say that we are working in refineries and we have hundreds of years of experience of handling hydrogen, the problem comes when this hydrogen goes into the nooks and corners of household, it goes to the car, it goes to the fueling stations. There the problem comes. There we need a worry of confinement. The confinement is the biggest challenge in case of hydrogen. Sir has pointed out that when we have done the risk analysis, the distances came larger than NFPA2. The reason is simple. When they have calculated, the risk is same, severity, probability is same, but when it comes to severity, number of people exposed are more. So ultimately, the risk is high. That's why you are increasing the distances. So I think the R&D facility infrastructure development, keeping the view of how to model hydrogen leakages, how to do the CFD analysis so that we can have correct placement of sensors. And in case of, for example, highly electrolytic electrolyzers, corrosion issues are there in case of alkaline electrolyzers. Again, the issues related to polymeric material compatibility is to be seen, because we are using a lot of non-polymeric material also in the what kind of a separation technology is to be, how you have to put the wall between a power source and the electrolyzer section. This is at the production side, the important thing is there. How to club the two facilities, whether you are interested in keeping the dispensing facilities as well as the storage facilities together. You have to basically do the analysis whether it is compounding risk or not, whether it is worth to club all the facility and make a very large facility or have a segregated facility. All these studies are required to be done. I think that's why the R&D infrastructure development and R&D ecosystem is also very important, so that we can get a good feedback and to counter effect the peculiarity of hydrogen and its behavior.
Yeah, thank you. That's a very good segue to our next section, and maybe we should keep it a little bit short. We are running out of time. But then Professor Mr. Pande mentioned R&D and infrastructure. We can develop standards, but also developing standards requires testing infrastructure, and that's becoming kind of a bottleneck as well. As of today, if you want to test an electrolyzer to understand degradation in lifetime, there are no standards, there is no test bed. You wouldn't know even where to go. And that, so that's the kind of, challenge we are facing. We ourselves in our study previously for MNRE identified 200 odd safety standards that need to be developed. In most cases, you'll need testing infrastructure to get to those standards. So how do we prioritize? We want to go quickly, but at the same time, the scale of challenge is, fairly big. So how do we prioritize? How do we move about, to make this process as smooth and quick as possible?
Yeah, I think that's a great question, but it's also a very difficult question, because at the end of it, in an ideal world, everybody wants every testing infrastructure. I think broadly, we all agree, and MNRE agrees, and they're putting a lot of funds into new testing infrastructure. The problem in the world is a problem of scarcity, right? We don't have enough funds to put everything we want overnight out here. And so that's why we need to prioritize. It's a bit of a chicken and egg problem, right? So we definitely need the standards, because without standards, there's no point in a lot of labs, because you don't know how exactly to test, and unless you have a careful formalism, you can't there's no interoperability, right? You can't test the results of different labs. So I think it's great that we have a lot of standards, so that part has begun. But now once you have a standard, if there is no testing lab, or the testing lab has a long lead time, or the cost is excessive, we know what people are going to do, right? They're going to skirt the standards, or other sort of solutions, loopholes are going to emerge. So we now, how do you prioritize? I think that's an interesting question. One of the things I think The answer is fairly, it's about systems. You need to analyze what is the roadmap, right? And I think you guys have done a great start. There's three stakeholders here. There is the testing labs, there are the end users, and then there are the standards. So once we map all of them, so suppose let's take liquefied hydrogen, that's probably going to come a little further down the chain, right? So if you have limited resources, the question is, what are the projects funded right now, and which projects are actually bottlenecked for want of a lab? And then, see, you can build a lot of labs, but then I've seen other projects where occupancies on instruments, and these are expensive instruments at times, are not high. So one of the things is to engage with the end users and figure out at least letters of intent or things like that, and figure out if I actually invested in this equipment for testing, what's going to be the occupancy. Second is frequency of testing, right? If you have some exotic test which is already being done at DLR in Germany or the American guys, you just need to do it once to prove a concept, fine, you could do it. But if it's going to be a frequent test, right, that's another problem. So these are the ways to prioritize. And again, I think we shouldn't reinvent the wheel. I mean, we should work with, there's a lot of facilities, and there's not a lot of them because these facilities are fairly expensive. But whatever they are and wherever they are in the world, we should identify them and figure out how we can leverage that knowledge in order to set up the test facilities out here. I think that's part of the answer to how you definitely need to build test facilities. But if we thought that we're going to build all of them overnight here, I think that's just not realistic. So I think a lot of what you guys are doing, just a careful mapping of what is the timeline, when is a facility which we need tomorrow, and when can we wait and do testing elsewhere and the facility comes up a year later, right? That's I think that's the exercise that's going to give us a lot of these answers.
Great, thank you, Professor. And you mentioned end user, and perhaps and this is just a out of the blue question, Sturle, but is there a role for the private sector to play in testing infrastructure, especially in areas such as transportation, where we're going beyond the traditional industry and actually into the space where it might actually benefit the end user to be a part of the infrastructure itself? So any thoughts along those lines?
Yes, in Norway, we do have test facilities and also certification. And it is extremely important if you want to develop the local supply chain. And I think that is one of the key things. If India wants to be one of the front runner also on the balance of the plant, everything needs to be tested on a production facility. This is not stronger, as they say, than the weakest chain. And that's why testing is needed for every part in a production site, a hydrogen production site. So it is a company called, there is many companies, let me correct it, there is a few companies around the world who have specialized in testing. Either it's an electrolyzer or the fuel cells and so forth. The Norwegian company, which is only one of several, which is owned by the Norwegian government, Greenstat and many other in the private sector, and also R&D institutions. Because this is something which I think could work very well, and what we are planning actually to do. I talked to two, but I've talked to many other companies who is doing testing, but in a different format, to bring this knowledge to India. So that would be a kind of a state of art. But of course, we would not have the capacity to fill the need in the market. So there needs to be this testing and certification plants or the facilities all over India to be able to develop local supply chains and also for export as well. And that's why we are coming back to the standards, that the standards need to be global. If not, you cannot export your products. You're limiting your market and you're limiting the growth. But more importantly, we cannot scale up because we need to bring down the cost of the plants. We need to bring down the cost of the storage. We need to bring down the cost of transportation. And that's why we need to work together. Because if we are working, as I said earlier, in a fragmented format, we are wasting our resources. And again, this is a common challenge that we have, and I think we can resolve it together. So
Thank you, sir. Mr. Aggarwal, electrolyzers is probably the first step because it involves production before we go downstream and talk about other standards. And like I mentioned earlier, we don't really have standards for understanding. There are electrolyzers of all kinds and all claims of lifetime and costs, etc. How do we understand those better without, having testing infrastructure? So what's BIS's, attempt to address this challenge?
It is a challenge, definitely. Standards on electrolyzer is concerned. We have developed the standards, and some efficiency part is concerned that is under development. But safety concerns, we have that in line. Now you're talking about testing of the electrolyzer. Testing infrastructure, so far BIS has not taken any step to install the equipment. But what I understand is ARAI is the front runner in this testing development of testing infrastructure. And I feel, as Peter said, that testing is very important, because having standards, having regulation in place, that won't suffice until you test the product. And even still, even after testing, you will encounter some kind of challenges when we bring the things on the ground. That is another thing. But that innovation will continue. And of course, we can't afford to put the life of the user on risk. So we have to be very careful while implementing these standards and regulations. So we have to start with the low risk areas. That is my perception. That let us start with low risk area. Let's not jump the gun, and let's not put the cart before the horse. Let us start at low risk area. Let us start implementing it, and then when we start the seeing the things at the ground, we'll have something coming out, evolving. And then on that basis, we need to correct the standards. We need to do course correction in the regulations as well. And that will, I mean, pave the path for future. But we can't put all eggs in the same basket. We need to go slow. That is what I feel.
Great, thank you. Step by step is probably the way to go. Mr. Rao, talking of step by step, one of the areas or applications that is being looked at for hydrogen or green hydrogen is the transportation sector, especially for heavy duty vehicles. Of course, the jury is out on whether it should be EV or green hydrogen, only time will tell. But one thing is for sure, if we need the range that we expect and the power requirements for HDVs, generally the talk is, for higher pressure vessel, 700, 750 bar. I know we have reached, 300, if I'm not mistaken, 350 bars. But, is 700 or 750 feasible? If so, how is PESO, looking at developing, those kind of vessels? Yeah.
Yes, yes. PESO has given some trial runs to major oil companies and OMCs for the testing of these engines as well as trucks at 350 bar, because the gaseous compression as well as the cylinder designed for at 500 bar, but as a trial run we are given for 350 bar. Why? Because we are handling the CNG at 250 bar, that is currently running. And the properties of hydrogen, if you see, and the latest technologies. And one more thing I want to tell you, this is a dynamic process, because all the standards and rules are not this thing. It will change according to the standards and the stakeholders' requirements and what are the safety inputs from the industry, because the amendments of rules are a dynamic process and the standards also dynamic process. So we will invite the innovations and technologies which are leads to the rules to be perfect. And regarding to the 700 bar, we are actually, if you have the infrastructure and robust design and pipeline and other facilities for the testing of the cylinders as well as the infrastructure facilities. And one more thing, actually, I want to tell, because it is a main thing. First of all, if anything starting, we have to first have some knowledge. Capacity building is the main concern. It is a pillar for hydrogen economy, because our capacity building and skill development, these are the two main things, because we have already having a very young engineers in India and we have very good manpower. So we can develop the skills and then we can make the hydrogen success. And already we are doing it in CNG. and we have to, we can do, I hope that we will do these things. And one more thing is the only factor is that we have lack of this expertise and experience. As a globally, we are very recently we have started the hydrogen mission, and we are already referring all the international standards and their what is the scope of the standard, what are the tests to be conducted, what are the prototypes, how it passes, how many tests to be done before cylinder come out from the manufacturing unit, and these what are the tests to be conducted, because there are a lot of tests to be conducted, almost 20 to 25 tests to be passed before coming into the cylinder to the use. And what are the filling facilities are there? We have to check that. What are the filling facilities? How to fill this with gaseous hydrogen? What are the compressor range? And what are the technologies? What are the electrical equipments are used for the compressions? Because of this, you can say intrinsically safe equipments and sensors. And what are the leakages in pipelines? And these things also need to be, because this is totally a knowledgeable subject. And we have to, first of all, do all the skill development and capacity building to know this. And it's not easy. I mean, it's not a big task. We can do these things because a lot of our manpower engineering, a lot of people are there in India. We can make these things perfectly.
Okay, thank you, Mr. Rao. Capacity building, skill development, and perhaps also to the extent possible, sharing testing infra. So, Jorgo, last question to you. How can we make that happen at an international scale? If we have to scale up quickly, as earlier panelists have said, we don't want to reinvent the wheel. But then how do we actually make those cooperations possible? I think there have been a lot of panel discussions, a lot of bilateral discussions on cooperation, but then on the ground it's not really happening as soon as we would like it to happen. So any thoughts, final thoughts on how can we make it happen? The previous mechanism you mentioned, between UAE and someone else, I guess is that the same platform, or is there a need to build something else?
Well, this platform was established now and is stable. It's always led by two countries. It's UAE and Netherlands. Netherlands will stay, and I think Brazil will take over, heading for the big COP in Rio. I think this is a platform that will be developed. However, what about the test beds? What about disseminating the results from test beds globally? I think also there we need a better cooperation. In Europe, we have established test beds publicly, but also privately. What is important are the certifiers who understand, is the standard tested and are the results coherent? And these certifiers, they are semi-public, sometimes they are even private. They have a lot of experience, but also responsibility, and we need to share all this. That's why we propose this idea of an international agency. This all needs somehow to be brought together. And we are not far away from that. But seeing the big push that India is giving to the whole hydrogen sector, really coherently with all the different aspects, I think India should be represented also in that international arena and should push it. Why not have the agency located here in Delhi? I don't know. If you go for it, you might succeed. But that's it. We need to bring all this together and to recognize each other, to also trust each other, to learn from each other. But that's the way to go. We are pushing that as Europeans, very much so, and happy to do it together with India.
Thank you, Jorgo. I think we have run out of time. Actually, we are over a little bit. So I'll close the panel discussion right now. Thank you very much for all the panelists, many of them coming outside of Delhi and traveling internationally as well. So really appreciate your time. In terms of the next few minutes, CEEW had prepared a standards mapping report a few months ago. More recently, MNRE asked us to do the same on testing infra. So we would like to make a really short presentation, 3 to 4 slides, 5 minutes, and then release the report. And then we can close with thanking the panelists. So I'll invite my colleague, Dr. Deepak Yadav. He'll very briefly talk about what the report is about, and then we can launch the report. Over to you, Deepak.
Thank you so much, Hemant. This will not take more than 5 minutes because I have got only 4 slides to present. I represent the Council on Energy, Environment and Water. We are a not-for-profit policy research institution based out of New Delhi. we use data, integrated analysis, and strategic outreach to explain or change the use, reuse, and misuse of resources. As you can see on the slides, we work across 15 focus areas, and we have 4 dedicated initiatives. I'll quickly move to the testing infrastructure facility part. So in the report that will be released today, we have mapped most of the hydrogen testing facilities available globally, and we have specifically focused on 4 continents, the North America, European Union, Asia, and also we have looked at United Kingdom as well. The key observation from here is that the most of the testing facilities, as pointed out by the panelists, are located out of Europe and North America. What we have also done is we have categorized the testing facilities based on the component of the value chain which is covered in those facilities. For example, for hydrogen labs, they have capacity to test hydrogen production and storage and transportation related components. Something like UL solutions located in the United States, again, production and other miscellaneous applications related to green hydrogen as well. We have also sort of categorized testing facilities based on their nature. For example, the ones that are indicated in blue, and you can see most of it is blue, are privately owned testing facilities. The green ones are indicated, they are the government-owned facilities, whereas there are few not-for-profit facilities as well. This was the global status. A few months ago, Ministry of New and Renewable Energy, and we were lucky enough to sort of partner with them. They released a compendium of standards across the green hydrogen value chain. And these standards are basically categorized into 4 types. Those which have been adopted or developed in India, and there are 86 of those, as you can see. So 86 standards, till a few months ago, have already been adopted or developed in India, and the breakup or the split is also given here. There are 60 standards till a few months ago which were under development, and further there are 58 which have to be developed, and there are 3 standards that we have identified which have no global standards. So this is where development is needed. So as far as standards development is concerned, we have made a significant progress. But where do we lack? We lack on identifying the testing infrastructure requirements. So for example, out of 86 standards that have been developed, with the data which is available with us, only 53 out of those 86 standards, the testing requirements have actually been mapped. And if you look at standards which are under development or standards which have to be considered for adoption, the testing requirements have not even been mapped, right? So that is the bigger challenge. In terms of standards development, there has been a significant progress, but now in the next phase, the focus should be on identifying the testing requirements and also setting up the testing infrastructure within the country. Hydrogen safety is one part, but what about performance related standards, right? And when we talk about performance related standards, the key is electrolyzer, because that is where bulk of the hydrogen production will actually happen. And I understand BIS is working on these developing these standards as well. But when we talk about performance standards, what are the various parameters that needs to be considered? First is the performance itself of the electrolyzer, and that is where we need details on things like specific energy consumption, right? And we need to have one common metric, just like we have for solar photovoltaic, 25 degrees Celsius, 1000 watt per meter square, to measure the efficiency. How do we sort of normalize the performance measurement of electrolyzer? That is key. And then there are various other parameters, like how do we sort of measure efficiency? Should it be at the peak load efficiency? Should it be the peak efficiency values, etc.? Second is durability of components, and we need accelerated bench test for few components. For example, the electrodes which are used, for membranes which constitute a significant portion of the electrolyzer cost. Adaptability to varying renewable energy is key, because in India, green hydrogen will basically be produced from wind and solar power. And therefore, what are the startup times? What are the shutdown times of electrolyzer? What is the hot startup time? What is the cold startup time, etc.? So we need performance measurements here as well. And similar to solar photovoltaics, where we have the IV characteristic, we also need to have a current density versus voltage characteristic for electrolyzers. And finally, hydrogen purity is something which is also of utmost important, because a few end-use applications like fuel cells, etc., are very, very sensitive to the quality of hydrogen which is coming in, right? So therefore, performance testing is also one aspect that we need to focus on. And finally, this is the last slide that I'll be presenting, which is what should be the action plan or the roadmap for strengthening the testing infrastructure in India. So the first point should be to expedite, the standards development, but also in parallel work on identifying the testing requirements for those standards, right? So both can go hand in hand. That is the first recommendation. Second is, as was discussed in the panel discussion, we need to develop a priority list of testing infrastructure. For example, having a testing infrastructure, a test setup for measuring the performance of electrolyzers should be the priority. Something like, as Professor Nabar talked about, something like cryogenic storage of hydrogen will come after a few years. That can be a medium priority kind of thing. But having those prioritization list and also estimating what will be the corresponding budgetary requirement, right? That will be the second priority. The third is, what we talked about, identifying and developing performance testing standards for electrolyzers, for fuel cells, for type 4 cylinders, whenever they are sort of, approved in India. The fourth aspect is what was debated just now on the panel discussion. Basically, how do we foster international collaboration? Especially if you remember the first slide, the global north has significant experience when it comes to developing testing infrastructure. Can we learn from them? Can we leverage from their experience and have, accelerate the testing infrastructure development in the country? That is the fourth recommendation. And fifth is similar to solar sector. Can we have a big role for the private sector to play in? Because globally, if you remember again the first slide, the blue ones, there is a significant role that private testing labs are playing in the green hydrogen testing ecosystem. Therefore, can we also have a similar kind of role? And can you sort of incentivize and support the private sector in India to come forward and develop the testing setup in India as well? Those are the 5 key recommendations that we have from the study. And perhaps now we can move to the report release.
Yeah, thank you. Can you just bring the reports and we launch the report?
Yeah.
Just to request all the panelists to just stand up and maybe hold the report. We'll release it for the public. So you'll be able to find a copy both on CEEW's website as well as MNRE's website, right away. Thank you again to all the panelists. Appreciate your time. I guess over to MNRE for the felicitation. Yeah, thank you.
Well, thank you all the panelists. Thank you, Hemant sir. May I now request Mr. Hemant to please present the mementos to all the panelists. May I request Mr. Jorgo to please come forward. Thank you so much, Mr. Jorgo, for coming and making this event possible. Thank you, everybody. May I now request Mr. Deepak Kumar Aggarwal to please come forward. I would request all the panelists to please stay here. We'll have a group picture later on at the end. I would request Mr. Srinivasa Raoji to please come forward. Thank you, sir. May I now request Shri Nawal Kishore Pande ji. Thank you so much, sir. I request Professor Rahul Nabar to please come forward. Thank you so much, sir. May I request Dr. Sturle to please come forward. And now this one is for you, Hemant sir. I guess
We'll just take a panel.
I guess I'll request all the panelists to please stand and please give it to Hemant, our moderator for the event. Thank you, Mr. Hemant. Thank you for the wonderful session and thank you to all the panelists. Thank you everybody for being here. I hope you all are clear with all your doubts. And I would request the panelist and Hemant sir to please come for a group picture. All right, so everybody, to all my delegates, to all my dignitaries, thank you so much for coming today. This was our second conference of Green Hydrogen 2024, and this was day one. Thank you. Wish to see you again. Thank you so much. Wish you have a great evening.